Section 7.1. We're going to talk about graphing quadratic functions in vertex form. All right, quadratic functions, that's kind of a new word for us. What's a quadratic function? This graph turns out to be a parabola, that's true. No, it's definitely not a straight line. Linear functions give us straight lines. Not quite like that, but you get the right idea. It's got a curve to it. It looks like a big U or a big upside down U. That's correct. If I write an equation on my piece of paper here, what will tell you that that equation is quadratic? It will be a polynomial. It's going to have 4, sort of. The biggest thing about a quadratic function is it will have an x squared. It will be a polynomial function with the biggest power, x squared. So quadratic functions look like this. F of x equals ax squared plus bx plus c. A cannot be the number 0. How come a cannot be the number 0? Well, no. If only a is 0, then we have 0 times x squared. This piece would be 0. And then we'd be just left with bx plus c. And what kind of function would bx plus c be? That would be linear. That would be a linear function. Okay? That's form right there. That's called standard form. And we will study standard form in section 7.2. Today we're going to study something else called vertex form, and we'll see what that is in a minute. But just interestingly, well, it's interesting to me anyway, why is this called quadratic? Where does that name quadratic come from? Well, you kind of mentioned it. There are 4 things in a sense, right? There's the y, and then there's 3 terms over here, so there's 4 things. So why did they choose to call it quadratic?
Can I have 4 answers?
Nope, it won't have 4 answers. In fact, an x squared thing, if you solve it, will only have how many answers? 2 at most. Well, the reason these were called quadratic is if you look at old universities in Europe, they all had an area in the middle, and all the buildings were built around the area in the middle. And what shape was the area in the middle? It was always a square. And what was it called? That area outside of this building here. What do you call that? It's called the academic quad, usually. And so, that's how this name quadratic came to be. It really didn't have anything to do with the fact that there were 4 terms. It had to do with the fact that it had an x squared in it. And squares were known as quads. And so that's why these became known as quadratic equations. So see, there's your history lesson for the day, too. You don't just get a math class here, you get a little history, too. Alright, so anyway, like I say, this is called standard form. A still cannot be the number 0, of course. We will study standard form in section 7.2. For today, we're going to study something called vertex form. And vertex form of a quadratic function looks like this. Y equals a times x minus h squared plus k. And we're going to learn in a few minutes here that these numbers, a, h, and k, are very, very important towards the shape and position of the graph of the equation. Okay? All right, well, let's start with the most simple, basic quadratic function of all. Y equals x squared. If I graph y equals x squared, I get that picture. And that picture has a name. Somebody already said it. That's called a parabola. That graph is called a parabola. This graph has one point known as the vertex. And what's the vertex of this function? In this case, it's the very bottom point, which happens to be the point 0, 0. That's known as the vertex. So if you have a parabola is going to have this basic shape. It's going to look like a big U, or in a minute we'll see that it could be a big upside down U. If your parabola is a big U, the vertex is always the lowest point. What if the parabola is an upside down U? Then it will be the highest point. So, the vertex of a parabola. This is either the minimum or maximum point. Depending on if the parabola is a big U or a big upside down U. All right, now we're going to start to learn what these letters in this formula do here. Which one do you want to start with? A, H, or K? K. All right. So to explore K, what I'm going to do is I'm going to have, there's the graph y equals x squared. And then I'm going to put x squared plus some number. Anybody got a good number they like? 9. Okay, so when we did x squared plus 9, we see here's our original parabola. This is our parabola y equals x squared. And then x squared plus 9, we see just a teeny tiny little bit of it. How come we see just a teeny tiny little bit of it? Because the vertex is now at 9 isn't really a good answer. It's at a point. It really should have an x number and a y number. 0, 9. So what did that plus 9 do to the parabola? It took the y and it just slid it up 9 spots. So let's just change our window just a little bit. I'm going to make my y maximum go as high as 20 maybe so I can see a little bit more of that second parabola. So there's the first parabola. And there's the second parabola, x squared plus 9. So what did that plus 9 do to the parabola? Moved it. Moved it which way? Moved it up 9 places. Okay? What if instead of a plus 9, what if I were to do a minus 2? It would be reasonable that it would take the parabola and move it down 2 units, wouldn't it? Let's see. Zoom 6, go back to my usual window. There's the original parabola y equals x squared. And there's the second parabola y equals x squared minus 2. What does it look like happened? It moved it down. Okay, so all this k does in this equation, y equals a times x minus h squared plus k. What does k do? It changes the... Well, it does change the y-intercept, but in a minute we'll see that h does something interesting too. All k does is it moves the vertex. Which way did it move the vertex? If k was positive, the vertex went up. And if k was negative, the vertex went down. So, k moves the vertex up or down. Oops. If k is positive, vertex moves up. And of course, once the vertex moves up, the whole rest of the graph moves up with it. And if k is negative, vertex moves down. All right, so now we know what k does. K controls up and down. Let's go to h next. What do you think h controls? Left and right, side to side. All right. So, oops, didn't want to erase that one. There's x squared. And now let's do x minus 3 squared. Is it going to move to the left or move to the right? To the left. Not really, but you've got the right idea. Well, let's just look at the pictures first. Here's y equals x squared, and x minus 3 squared. Which way did it move? It moved it to the right. So if I have a x minus 3 inside my brackets, then move to the right. So what? Notice that this formula has x minus h in it already. So the minus is already there. So what number did I plug in for h? I plugged in 3 for h. But the formula already has a minus built in. But if I plug in 3 for h, 3 is a positive number, the graph went to the right. Now what happens if I plug in a negative number? So if I plug in a negative number, I'm going to have x minus a negative number. But how would we usually write x minus a negative number? We would write it as x plus. So what if I do x plus 2? Here's my original parabola. And the x plus 2 moved the graph to the left. So, just as k moved the vertex up and down, h moves the vertex which way? Left and right. H moves the vertex left or right. If h is positive, then you end up with something that looks like x minus h squared. And this is where it gets confusing. When h is positive, because our original formula already had the minus built in, I'm going to end up with x minus h. That's a right h units. So this one you got to watch out for. When you have the minus inside the brackets, the minus sign actually moves the graph to the right, which is kind of backward of what you would probably guess. You would normally guess that x minus 2 is going to move it left 2, but it actually moves it right 2. And if h is negative, then I'm going to end up with something that looks like x plus h squared. And this one moves left h units. So what I always tell my students is left and right works backward. Okay? Up and down works perfectly. If k is positive, then you end up with a plus k on the end and it moves it up. Makes perfectly good sense. But here, if h is positive, then you're going to have an x minus h, but it still moves it to the right. All right, so I might give you a problem like this. Y equals x minus 2 squared minus 4. I want you to tell me the vertex. Excellent, except you would write it the other way around because you would put the x's first, wouldn't you? So what's this minus 2 inside the parentheses going to do to the parabola? It's going to move it right 2 units. So my x number is going to be 2. Right, you gave me the right numbers, you just gave them in the wrong order. And then this minus 4 is outside the parentheses. That controls up and down, so that one's going to be down 4. So our vertex should be the point 2, negative 4. And then what if you wanted to graph this parabola? I'm going to build a graph here. Here's 2, negative 4. I'm going to draw it right there. And what I would like to do is I'd like to have a couple of points on each side of the vertex. So generally if my vertex is 2, 4, I want to pick two x numbers bigger than 2 and two x numbers smaller than 2. So what are your two favorite numbers bigger than 2? 3 and 4. So I'm going to plug in 3 and 4. And then what are your two favorite numbers smaller than 2? 0 and 1. Except I'm going to write them this way, 1 and 0. Alright, so I plug in 3. How much is 3 minus 2? 1. 1 squared is 1. 1 minus 4 is negative 3. So when I plug in 3, I get negative 3. Then I plug in 4. If I plug in 4, I get 4 minus 2. 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. So I'll mark those 2 points. 3, negative 3 would be right about there. And 4, 0 is right about there. I'm going to change my mind. I'm going to write these as 0 and 1 again. I don't know why I thought I should write them in backward order. That doesn't make much sense to me. Alright, now I'm going to plug in 0. When I plug in 0, I have 0 minus 2. What's 0 minus 2? Negative 2. Negative 2 squared is 4. 4 minus 4 is 0.
So does that happen a lot?
What does what happen a lot?
If you plug in 0, it ends up being 0? Or it's just because of the number related?
Happy accident. That's all. When you plug in 0, you won't usually get 0. That was just a happy accident. When I plug in 1, 1 minus 2 is negative 1 squared is 1 minus 4 is negative 3. Now, there is something that happened that is not just a happy accident.
That you have the same number.
It just so happened those two numbers matched and those two numbers matched. That was not a happy accident. And that's always going to happen. And here's the idea. My vertex is at 2. How far away is the number 3 from the number 2? 1 unit away. And when I plugged in the number 3, I got the answer negative 3. On the other hand, how far away from 2 is the number 1? It's also 1, and I got the exact same answer, didn't I? I got negative 1. I got 1, comma, negative 3. That's always going to happen. There's always going to be a nice symmetry property for these parabolas. If I go 1 unit to the right, I'm going to get a y number. If I go 1 unit to the left, I'm going to get the same y number. And the same thing happened here. If I started at 2 and I went 2 numbers to the right, I plugged in 4. When I plugged in 4, I got 0. If I go 2 numbers to the left, that's going to be 0. When I plug in 0, I also get 0. So parabolas have a nice symmetry property. And the symmetry property is, if you draw the line that goes right through the vertex, the vertical line that goes right through the vertex, what should happen? You should get a mirror image. So when you go to calculate points, you really don't need to calculate more than 2 of them. Because if I calculate 2 on the right, the 2 on the left are going to have exactly the same y number. You really don't need to figure out 4 points. You really only need to figure out 2 points. All right, let's do one more of those. And then we'll talk about the A number. We haven't talked about the A number yet. What does the A number do? Y equals X plus, anybody got a number they like? 5 squared. Then how about another number? How much? 7. Positive 7 or negative 7? Negative 7. Negative 7. Okay, the first thing I would ask you on this problem is, what is the vertex? The vertex is always a point, so you're going to list it as a point, like so. And you would tell me the vertex is? Negative 5, negative 7. Why is the vertex negative 5, negative 7? The plus inside the parentheses moves it to the left, and the minus outside the parentheses moves it down. So that one goes left and down. All right, so now we're going to draw a graph here. Negative 5, negative 7 is right about there. I'm going to pick two numbers bigger than negative 5. What are my favorite two numbers bigger than negative 5? Negative 4 and negative 3 are the two I would pick. And then I also want two numbers smaller than negative 5. Negative 6 and negative 7. All right, we plug in negative 4. Negative 4 plus 5. 1. 1 squared is? 1 minus 7 is? Negative 6. I plug in negative 3. Negative 3 plus 5. 2. 2 squared? 4 minus 7. Negative 3. So I'm going to draw those 2 points. Negative 4, negative 6. And negative 3, negative 3. Without doing any work, what's going to happen when I plug in negative 6? I'm going to get negative 6 again, aren't I? And when I plug in negative 7, I will get negative 3. Very good. So I don't really need to figure those out. As long as I'm confident that I plugged in negative 4 and negative 3 correctly, then those other two would have to be exactly the same. There's my parabola. All right, so the last thing we need to do is we need to figure out what the number a does. So if I have y equals a times x minus h squared plus k, we know what h and k do. What do h and k do again? K is up and down, h is left and right. All right, so let's take a look at a. Y equals x squared, and how about we do y equals 3x squared. So let's put a 3 in front there first. So there's my x squared, and then there's 3x squared. Did it move the vertex? No, it did not move the vertex at all. What did it do to the parabola? Made it narrow. And this is kind of deceiving because it looks like it's more narrow. What it really did is it made the parabola more tall. What's the difference? Well, here's what I mean by that. If I were to take y equals x squared and take y equals 3x squared, and I were to build a little table, if I plug in 0, I get 0 for both of them, don't I? What happens when I plug in 1 over here? I get 1. What happens if I plug in 1 over there? I get 3, don't I? If I plug 2 in here, I would get 2 squared is 4. If I plug 2 in there, I get 12. What's not changing, the x numbers really aren't changing. To say the graph is getting skinnier would imply I'm changing the x numbers. The x numbers don't change, 0, 1, and 2. What changes? What gets multiplied by 3? The y numbers. So I agree that it looks like the graph is skinnier. But what really happened is you grabbed the top of the parabola and you pulled it up. You stretched it upward, which makes it look skinnier, but it's really not skinny. It's really taller. Okay? So if I multiply by a number like 3, it makes the graph taller and skinnier, if you want. What happens if I multiply by a number like a half? Well, if multiplying by, ooh, boy, I got my things in reverse order there. If I multiplied by 3 made it taller and skinnier, what do you think multiplying by a half is going to do? Shorter and flatter, shorter and wider. And I think that's absolutely correct. So multiplying by a 1/2, what that really does is it multiplies all the y numbers by a half and makes the graph spread out more. So what does the A control? It controls the width, the height really, but it controls the width. If A is a big number like 3 or 4, it makes the graph tall and skinny. If A is a number like a half, it makes the graph short and wider. What if A is negative? It flips it upside down. That's how you get your upside down U's. So if I do negative 1/2 times x squared, there's my x squared, there's my negative 1/2 x squared. So the negative flips it, and then the 1/2 makes it spread out more. Okay? So A controls two things. A controls direction. When A is positive, you're going to have a big U. When A is negative, you're going to have a upside down U. And then A controls how wide it is. If A is a number bigger than 1, it gets tall and skinny. If A is smaller than 1, it gets short and fat. All right, so A does two things. A times x minus h squared plus k. A controls direction. A is bigger than 0, you get a big U. A is less than 0, you get an upside down U. And then A does another thing. If A is bigger than 1, the parabola becomes tall and skinny. And if A is less than 1, the parabola becomes short and fat. Okay, we will look at some more examples of that next time, but we're kind of out of time for today.